Boom. Omer,
Boom.
ready?
I am ready.
And action. No props. No props.
Action.
No props. Okay.
Action.
Hello, everyone, and welcome to the 18th episode of DevOps Topics,
Wow.
where we write
Wait,
topics with a
80?
typo.
80 or 18? 1-8 or 80?
18. We like the th.
Okay.
It's important.
Yes.
Okay.
Very.
Where we write down topic with a typo. Well, not a typo, but a known spelling
Because
error.
apparently it's a
Yeah.
thing. You need to write things with a typo.
Mm-hmm.
Lift.
And
Yeah.
and today's topic for the 18th episode is VPC, which stands for Virtual Private Cloud. And of course, we love to
You
start.
ruined the surprise now.
We love to start, but well, we need to tell the acronyms. I love the word acronym.
Yeah.
So, Omer,
Maybe we should change it into an English lesson rather than a DevOps
I
podcast.
might do like a sidekick.
More
It will be
audience.
like a side gig,
Okay.
sidekick, side gig. You'll be my
Yeah,
sidekick in the side gig.
I can do that.
Okay. So today's topic is VPC. So Omer, what
Yes.
is the first thing that comes up to your mind when I say VPC, except from Virtual Private Cloud?
Okay, I have a lot to say, so your job is to just stop me from talking, I think,
Okay.
in regards to
Okay, I
VPC.
will clap when I want you to stop.
Yeah, say the safe word.
Okay.
The safe
Okay,
word.
say for this clapping.
Okay. VPC. Let's give a background. We both work on AWS. Any kind of terminology, any kind of concept we talk about can be easily transferable or translatable to other clouds. What we're going to say here, everyone has, especially Azure, GCP, same like AWS. I'm sure that DigitalOcean and others will probably work the same. But I know for a fact that Azure and GCP do, so just like a small FYI. VPC is your way to encapsulate, great word, encapsulate network resources. What it says on AWS is, like you said, virtual private cloud. Back in the old days, I used to have a way to deploy stuff that are not part of my network. You could, for example, pick an EC2, which is an instance, and just start a server in the cloud without having to mention where it's running. Those days are gone. It used to be called EC2 Classic, I think, and today you don't have EC2 Classic anymore. You just have an EC2 that has to sit as part of a virtual private cloud. If you don't configure one, AWS will provision one for you. That's one thing I think you and I need to discuss, whether you're using that or not. I'm immediately saying no, don't use the default VPC for a reason we'll talk about in a sec. Create your own. Two main reasons. One, you may probably, especially if you're building a production robust network, you want to segment it in a certain way. The other is you need to know what's going on in your VPC, and I'll say why in a sec. That's the basics. Okay, why would we need a virtual private network? This is a way to create our own network. Simple as that. And define IP ranges, define where we want it to sit. When I say where we want it to sit, a VPC has to sit on a certain region. AWS has like whatever, 20 plus something regions, which are different locations in the world. Each region is divided into what we call AZs, availability zones. It can be from 1 to 2, 3, up to 6 or 7 in the big ones. Maybe Virginia is the biggest one in the world. In any case, you can decide those. So a VPC is segmented into subnets. Subnets are parts of your network and are different segmentations. You can break them down into different IP ranges, and you can define them in certain ways. These,
Omer,
each subnet,
subnets
yes.
are sub-networks of your network.
Boom!
Just saying, they
It
are.
took 30 something years to discover
Yes.
that. Okay, that's
Yeah.
great.
Okay.
Okay, so your subnetworks are ways to separate it. The main two types of subnets on AWS are private and public. Very easy. What makes a subnet private or public on AWS? When you create a subnet, you need to route it to somewhere. If you don't add anything to a routing table, then every request that's coming out of this subnet will be rerouted into the subnet. So you can only communicate within things that in your subnet. For example, I have two servers in a certain subnet. There's no connection to anywhere in the world. They can speak between them. If you try to download something from the internet, maybe run pip install or npm install, it would not work. two ways to make a subnet communicate with the internet. One, connect it to an internet gateway. That would allow you to communicate with the internet back and forth. Back and forth, I mean you can route requests starting from your internal servers, and you can communicate from the outside world. If you have an IP attached to a server, I can reach out from the outside world, given that the firewall, as in security group, is open and lets me communicate. For example, I want to go to HTTP, I can talk to the server if it's on the public network. If I put my server in a private network, I can either not connect it to anything, or like we said before, maybe I want to run pip install, I can attach a NAT gateway. NAT is a, do you remember what it is and what it stands
Network
for?
access, network address translation.
Nice, I've never known that.
Okay.
So NAT basically is your way to run a protocol that's called DHCP, and that's a way to get requests from the other outside world or wherever and translate that into an internal
DHCP, Dynamic Host Controller Protocol. Unless I made it out. And, okay, so this I might, yeah, I might like maybe I just shut it out. Yeah, I'm not sure. Maybe.
It sounds great. So again, what it does, it takes an incoming public request and translates it into internal IP range. And what that lets us do is a one-way filter that lets us communicate outside. If I want to run pip install again, I'm running outside to the world, installing something from the internet. But if something wants to communicate with me and initiate a connection, it doesn't know who I am, because there's one public IP or a few, doesn't matter, but it doesn't know my specific address under that thing. Your router in your house serves the same purpose, by the way. It's also a modem, but also a router. It takes a public accessed IP and translates it into many devices. That's it. Was that enough? We can go a lot further and deeper, as you probably know, but that's the basics of what a VPC is.
Okay, so I want to even take it like, okay, I want to take what you just said and lower it to the home level, just like you started with the router thingy. So, for example, just to give a few examples to the listeners, viewers, anyone in the crowd, the crowd, okay? So anyone who listens, that if you're at home and you are connected to the internet, let's say you're viewing us now or listening now, so you are connected to the internet. So what happens is, as Omer stated, like there is like your home is sort of like a virtual private, well, not cloud, but network. Okay, so you're in your own network, and your gateway outside is, as Omer mentioned, the router. Now, in some homes you have multiple routers, but you only have usually, in a home, a single point of access to the internet, which is provided by your internet service provider, by your ISP, which you pay for each month. So every month you pay to your ISP. In each country, it's different. Let's take, I don't know, United States, for example, maybe T-Mobile or Verizon or AT&T, or, I just said, I think mobile companies, but I think they also provide internet services to local homes. And through that router, there's also a modem, right, or some component that lets you access the outside network, right? And this is sort of what's happening in the cloud. So as Omer said, like your computer is like a machine, which is in AWS is an EC2, right? So if we start comparing, so let's say my laptop, which is connected to the home network, is an EC2, is a virtual machine, but it's a real machine. And the router is, as Omer said, an internet gateway. So at home, you usually don't have, network access like NAT gateway, right? Usually you don't have that component. Usually it's only in the cloud for its purposes, for going outside with a single IP and to protect private resources, blah, blah, blah. But at home, the router is enough and you can access the outside, though the outside world cannot really access you because you got all of those rules and whatever. So in case you're not really aware of what's going on, like what's the cloud, and now you can know that according to your house, you can always compare. Like think of it like at my house, I have my subnet, which is, usually at home you will use, 192.168. Yeah, exactly. Those numbers, or maybe exactly like 10, 0, and those private subnet numbers. So we also use them in the cloud. Right, so that's the same thing. Okay, so now.
So I want to take what you said exactly and take it to the next level.
This is
home use.
Yeah.
In the cloud, we more often than not, especially in production, we want high availability. And I said something about having different AZs and different subnets. A subnet spans across an AZ, meaning I can put 2 or 3 different availability zones. And what that gives me, especially about what you said, at my home, I'm paying an ISP, right? If I fail to pay, or the ISP fails, or the infrastructure fails, I'm disconnected from the internet. But when I have a backend server in my production account, I can't I can't live with the fact that only one connection. This kind of everything depends on this one connection. I want high availability. In order to do that, I might want to consider, or you should consider, spanning across multiple AZs, at least 2. And this way, I have a load balancer on top of that. I think you mentioned that before. A load balancer can actually span across multiple subnets, across multiple availability zones, and it can have, we call it little legs or foots. It can have 1 foot here and 1 foot there, and it can take requests from the outside and route them between those 2. And then you can have 2 different instances, but they serve the same purpose. One sits on one availability zone, the other is on the other. Both are connected independently to the network. And then if one fails, the other can start taking requests, all of the requests instead of this one. There are ways to even leverage that in the DNS level and always send health checks, seeing that the actual backend server is valid. The load balancer does that on its own. So you don't have to work all that hard, especially on AWS. ALB, that's what it does. You give a certain type of health
But
check
what is
for
an ALB,
instance.
Omer?
An ALB is an application load balancer.
Okay, and what is the
that,
difference between, you say ALB, what's the difference between ALB and, I don't know, NLB maybe?
Okay, NLB is a network load
So
balancer.
why would I
They
use,
both
like,
work.
when do I use this, when do I use that?
Right. Okay, let's get into that. A load balancer, basically what it does is distributing the load that's coming in from the outside across multiple servers. That's the essence of it. In AWS, we used to have a classic load balancer. I think that's kind of deprecated. We have main 2 others. Are there more? Main 2,
That's
right?
the only ones I know,
Application
yeah.
and network. Right. Network, more often than not, is used for, like we said, network traffic, more on the TCP level. That would be layer 4 in the scheme. 3? Okay, it's 3. So that operates on that level, and for that reason, it's very, very fast, much more than an application load balancer. That's not a slow load balancer, but it serves its purpose in a, let's call it a more native network way. Application load balancer, on the other hand, works on the 7th, 6th, somewhere higher.
7, yeah. somewhere out there, yeah.
Yeah.
I think it's 4 and 7, by
a...
the way, something like that. I think that's the difference. Like this one
Okay,
is 3, that the
sounds
other
right.
one is 4 and 7.
Yes. So usually the protocols that it works in are HTTP, HTTPS, and it has features that serve more an application rather than a network traffic. That can be SSL termination, health checks to HTTP endpoints, which is what I said just now. You can actually make it sample HTTP endpoints on the servers and understand whether something is up or down, and then decide where to route to. It has a lot of more features. For example, if you deploy that on top of a target group on an ECS cluster or wherever you use a target group, you can define rules that tell the load balancer where to route a certain request. Maybe I'm going to /application or /health or /debug or /something, and based on that, it can take the request and route it somewhere else. That can work on the subdomain level. Maybe I'm requesting app1.mycompany.com. That would be one endpoint, and app2.mycompany.com that would go someplace else. And ALB, can do all of that for you. Where were we? Okay, so that can sit on top of the applications, listening and serving 2 availability zones for high availability, and route the traffic between them. That's it.
But I need the cutoff. Like, okay, so I'm new to AWS. I heard about the concept of the load balancers because I heard the DevOps Topics 18th episode. So I heard about it.
Mm-hmm.
And then I went to AWS, navigated. I went to the EC2, VPC, whatever, load balancers. And then I had the choice of creating, like, I have my application. I have, as Omer said, I spread my EC2s over 2 availability zones. I'm trying to create a load balancer, and then I'm like, wait, which one I should choose? Application load balancer or network load balancer? And I'm like, wait, I'm not sure. Which one should I choose? Well, how would you say
Okay,
the cutoff? Maybe what's the main reason for you to choose this one over the other one?
So it's a good question. It depends on what you're serving. If, for example, like I said, you're running on top of a fleet of EC2 instances or an ECS cluster that's serving a web application that's working in either port 80 or port 443, but they're accepting HTTP access from the internet, you need an application load balancer to be able to work on that level and serve the requests. If, for another example, you are serving a VPC endpoint, and we didn't talk about VPC endpoints, but we will in a second, but you're serving something else, a network access gate that takes incoming TCP requests and need to route them somewhere on the network. It can be all kinds of packets, any type of TCP access, right? Any kind of port in the world you can think of, I can route that through a network load balancer, especially if that thing is going to be a single point of failure that needs to be very available, very robust, and needs to operate across a lot of more requests and is operating on the TCP level. That would be a network load balancer.
Okay.
I hope that answers.
Yeah, I think okay. I'll give my 2 cents. I think they are 2 cents about it. Like very very simple decision for me. Okay, I think usually I'm like, okay, I'll take this one. But for me, it's like, okay, I need a static IP address. So if I need to serve my application with a static IP address, because God knows why. Okay, maybe I need to be whitelisted somewhere. Maybe my users are hospitals, and hospitals only whitelist specific range of IP addresses. So maybe my application needs to be served as, with a static IP address. So I'll take a network load balancer, just to give one example. And if my application, like if I don't care about static IP addresses, for example, so I'll probably have more benefits of the application load balancer, because it also includes if I need it, not sure if I do, like if I can use the Web Application Firewall because I'm on the 7th layer, so I have WAF, right? WAF.
Yeah.
So I can use the Web Application Firewall. Having said that, if you're using maybe Cloudflare, which provides a proxy to your DNS records, so maybe you don't need the WAF because everything is already protected in Cloudflare, and you can add the network. I don't know, like you can also protect your network load balancer with that, with Cloudflare.
Right.
So it really depends on what you use. Just saying my rule of thumb.
I think we mentioned WAF, and it's worth getting into WAF, but in a little bit. I want to finish a few topics before, but yes,
shoot. So what else do you want to talk about?
So before I'm going into VPC endpoints, which you mentioned, I just want to finish the idea of having subnetting in the VPC, although it sounds like we are done. So we talked about having the public option, the private option with NAT, and the complete private option with no access at all. 2 things about that. First, if you need to start locating things, by things I mean EC2 instances, databases, load balancers, you need to decide where to deploy them. An application load balancer, for example, or any type of, let's go for application load balancers, probably is accepting requests from the internet, and it needs to route them within the network to private subnets. So you would locate your application load balancer. It can also be Nginx or any type of proxy that needs to be accessible from the world in the public zone. So in public subnets that are connected to an internet gateway. Your application backend servers, regardless of whether that's Kubernetes nodes or ECS or just EC2, anything that's a backend needs to sit in your private subnets, more often than not with a NAT gateway, because it needs to be able to access the outside world. You don't want things to come into it on their own. Make sense?
Makes sense.
And lastly, if you have things that don't need any type of access, which means they don't need to access the world, you don't want the world to access them. The only thing you want accessing them is your backend application. Any idea for a type of resource that answers to that?
Like the VPC, are you referring to the VPC endpoint S3 or something? I'm not sure.
No, you're thinking like an ops engineer. Okay. I'm trying to, you're going ahead. No, I meant databases.
Okay.
Databases, the only thing they need to communicate with, I think like 9 out of 10 times, that would be your backend application. It needs to query something from the database and respond.
Also, only inbound connections, no outbounds.
Exactly, that's it. Only inbound. It needs to come in from the VPC, stay in the VPC.
Sort of, because databases do need updates. But if you use a managed database, so the cloud provider like AWS
so
updates it for you.
There are a lot of caveats. Definitely.
Yeah.
There are a lot of caveats. If your database is managed on an EC2 and you're running, by the way, I hope you're not SSHing in and trying to update the database. I hope you have some kind of rotation mechanism, maybe with an auto-scaling group, something like that, and a user data that's installing it. But yes, if you need to install the patches and it needs to access the world, it needs to be in a NAT. If that's not the case, please put it in a private subnet with no access to anything other than the backend servers. And the way you do that is you locate security groups on top of everything, and you can decide for the security group what it allows in and what it allows out. Usually the out we don't care about it all that much, although you can and you should. But we care about what comes in. The database should only allow the port for the database. For example, 637, I wouldn't try to remember ports now, but you need to access the specific port for the specific database. Same goes for the application, which probably listens on a special port, 8080, 5000, 4000, doesn't matter what. And your load balancer needs to accept 443 for HTTPS. If you wanted to listen for 80 and then route it to 443, never mind. Just make sure it's protected, make sure the traffic is encrypted, open only the ports you need in the security groups. And that is a complete answer to a question I ask in interviews and I never get the right answer.
So all you gotta do is tell them, listen to this episode, and that's it.
Yeah, that's why I wanted to do it.
Okay, give like an easy answer to that. All right. But you gave like a full architecture of fully blown application, that's like a big thing.
Yes. Correct.
Okay.
Correct. I think it's important.
So yes. I have a gut feeling that you got like tons of things you want to talk about. So I feel like I'm giving you the mic this time to say what you want to discuss about, because I feel you have a lot to say about this topic. Unless you want me to start shooting questions like I always do.
No. One more thing, which we talked, I think we mentioned something, so it's important we go ahead and talk about it. Do you want to talk about VPC endpoints?
Shoot.
All right. VPC endpoints. That's it. Let's move on to the... Kidding. VPC endpoints. Important concept on AWS that lets you do basically a main thing and then the other. The main thing is that you can route things internally. What do I mean by that? The most simple example is S3. Okay, so you can provide internal traffic, a way to go without going, okay, I want to query something from an S3 bucket. My application is working with an S3 bucket. Instead of each time I want to access the bucket, I need to access the world through a NAT gateway, for example, go to the internet, then back to S3, then fetch the thing, then go back, then download it. I can use a VPC endpoint for S3. And by doing that, I get multiple things. First of all, I don't have to use a NAT. NAT gateway, not only it costs money, it means you're less secure because your request is rerouted through the world. If I'm going through a VPC endpoint, everything is going through AWS. So it's called the AWS backbone, and you're already on AWS, so the routing is shorter because it sits already on their infra. It's safer because their infra is more isolated, protected, and whatnot. And it's faster, of course. But one caveat, VPC endpoint also costs money. So you always need to find the sweet spot between what am I doing? What am I optimizing for? Is it speed? Is it costs? Is it security? So just keep that in mind. And what you also can do is create custom VPC endpoints. So for example, if you're a security company, just an example, and you're serving customers, a lot of customers wouldn't want the agents or not agents or whatever is scanning their account to bring back and forth requests over the internet, even if they're encrypted, even if I don't know what. A lot of them will ask you to route it through AWS because maybe your customers are already there. You can create a custom VPC endpoint and have the entire communication use or leverage the AWS network instead of using the internet. And that's safer and faster. That's it.
Now that you mentioned it, maybe Mongo Atlas is using it, because I know that Mongo Atlas provide, like if you're on AWS, and Mongo Atlas provide you like a way to connect
Mongo Atlas, Redis, Elastic, all of these. Yes.
Yeah. So they probably use something like a custom VPC endpoint, so you'll communicate with them, maybe. Just a guess because what you just said. Okay. Yes. So, by the way, you remember I told you about the VPC endpoint and ECR? It can also save you a lot of money instead of going through NAT gateway, as you said, because NAT gateway and also VPC endpoint, you pay both. You pay for two things. One, per hour. Second, for traffic.
traffic.
Yeah, and traffic usually costs even more than our, depends on the usage, right?
Very much so.
Okay. So,
Perfect.
any other topic you want to talk about, Omer?
I think that covers it for the most of it. We can talk a little bit about stuff that are global. Okay, VPC endpoint is a global thing on a VPC. Another type of global thing is NACLs, Network Access Control Lists. I didn't win the competition of acronyms, but I got one.
Yeah, you did, you did.
So this is, correct me if I'm wrong by describing it, but this is kind of your way to have a global security group on top of your entire network. So a NACL can actually is more of a firewall. So you can put a firewall on your VPC, attach it to your VPC, and then decide globally what comes in and what not. For example, I can block all SSH access. Everything that comes into port 22 is going to be blocked from now on. I can also block it on the IP level, or just the IP level, I don't remember. But I can put rules to define that a certain CIDR block will never be able to access your network. Maybe as means to block a DDoS attack. Maybe as means to block just certain countries that you don't have anything to do with. So these are NACLs. Anything you wanted to add?
Let's say, so security groups are usually more applicative. You can also, okay, so security groups are for allowing, usually. Well, not usually, but security groups are for allowing because they are blocked by default. And knuckles, you need to allow and block on both ends, right? Remember, I think
you told me something about one being stateless and one
yeah,
being
yeah, yeah.
stateful, and I
We
can
had
never
we,
remember
we had
which
an
is which.
episode about it. So usually, like when I think of security groups, I'm like, okay, this is more applicative, like which maybe subnet or maybe which other security group I want to allow, inbound connections to my application. And knuckles are more on the, I think as we said, level 3, which is, like the TCP level where you block CIDR addresses and whatever.
Makes a lot of sense.
This
Yes.
is how I separate when to use this, when to use that.
All right. I think the last thing that we touched on and just didn't expand, and it doesn't really have to do with VPCs, but we touched about on WAF, so we can say 2 sentences about WAF. And it's funny because I had an interview last week, and I didn't mention it, but the interviewee brought up WAF.
So we started barking like waf waf and stuff.
Yeah, exactly. Okay. How do you
know? That's me. I know.
Sorry, I wanted to know. And WAF is important, but it's also important to understand what it does. So WAF is a web application firewall. So it's kind of like a normal firewall that can block an IP or a port, but this is more of a rule engine. So I think AWS have their own certain rule sets, surely Cloudflare do, and that's your way of blocking weird accessed requests, let's call them. So what hackers will normally do if they want to attack you specifically or just scan, they will try to inject weird requests with all kinds of weird characters and null point, I forgot, null byte, whatever. They'll try to inject stuff and make certain requests to see if you respond to some of them. Maybe just generic requests. Maybe they're expecting an Nginx answer and they want to try and hack this Nginx, and they'll try send all type of requests with all types of strings onto your system, and a WAF can just stop that for you with the default set of rules. And if you know something's dangerous on your own, you know your application, you know your API gateway, you can add your own rules and have them blocked on that level, and then the request never gets to your infrastructure. So you don't have to, first of all, you offload stuff because you don't have to deal with them on the application level, and second of all, you stay protected.
Cool. I want to give a simple example of WAF, and then we'll move to the corner of the week. So I'll just give a very, very, very short use case, all right? So assuming your company has a VPN, okay? So a VPN usually has a static IP address. So everyone in the company, maybe in the office, has one IP address or from home. So usually you have like a set of IP addresses which you can say, okay, these are safe addresses, right? And assuming your application is behind the load balancer, which is behind the web application firewall. Cool. So in the web application firewall, WAF, 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 you can add a rule which says, let's say I want only employees to access the path in my application, which is /private, okay, according to path. So what I can do is add a rule which says /private enable access only to the set of IP addresses of the VPN or Office or whatever. So this way, my application is protected, and no matter what happens, anyone who tries
That's
to
interesting.
access,
I've never thought of that use.
it's like a very simple use case. Usually, this is the best way I think to realize that WAF can be as simple as that. No need to do tricky stuff. You can also use what you said, which is, I think there is a CloudFormation template for that. But I know there is a CloudFormation, like security automations, which is a big thing against SQL injections and stuff like that.
Exactly. Yeah.
So putting that aside, if you just want to block access to your application and make it available only to specific things, maybe /backend /whatever, you can do it with a WAF, which is very simple.
Yeah.
Even manually.
It's like zero threat for the poor. Yes.
Yeah, I mean, it's very, very simple. You create like a set of IP addresses, you add it, and then you don't even need to redefine the rule if you want to add more IP addresses or remove them. You just use the same set, and
that's a great option.
I mean, super easy.
By the way, the SQL injection is the best example for WAF, because if you read any type of manifest for SQL injection, all the tests look more or less the same, with question mark and try to use the one quote, the single quote, and then try to add like a hash or something. There's a set of most likely SQL injection strings that would work, and WAF will just block them out of the way. That it'll remove all.
Also weird traffic, like maybe bursts of traffic from a weird place, so it can automatically do stuff. Okay, ready for the corner of the week?
Let's do that.
Okay, effects, boom, boom, corner of the week. All right, yeah. Think about it, like when people don't see me, they like how it sounds.
What is going on?
Yeah. Okay. So, corner of the week. Omer, what was your experience or technology that you discovered, or story, or task, or anything you want to share that happened to you this week, last week, or last year?
Okay. Apparently, if you're considering to build a Kubernetes cluster, or maybe you're already running one, but you are thinking about your ingress controller. If you've researched this field a little bit, you probably know there are tons of them. We can just think of 4 or 5 out of the top of my hand, for sure. There's apparently a docs, a public Google Sheets, I think, document that you can find online. I'll add the description in the show notes, and that has pretty much all of them, and they're segmented into all kinds of, it measure features like which protocols are supported, features, routing options, all types of stuff in this huge Sheets document that's very public, and then tons of readers, like hundreds of people are connected every second to read it. So I'll add that, and it's really cool if you're considering a replacement or a new one. So that's for you.
Wow, cool. So just before I move to mine, you said you can just shoot 3, just so we have the audience, like you said, ingress controller. So just shoot the 3 ones that you are familiar and love.
Nginx, Traffic, and Kong.
Those are the exact ones that I would say. Yeah. I'm shocked. Yeah, those are the exact ones. Seriously.
Yeah.
Yeah, and also Traffic, I like to say Trafic because I think they are French, right?
Really?
Yeah, I think so.
Really?
Yeah, they say Trafic. Yeah.
That explains a lot of things.
Right? Yeah.
You now complicated. I cannot unhear this, and now I have to say it like that even in my head forever. So thank you.
Yes.
Trafic.
Exactly.
Baguette.
Okay. Okay. Moving to me. Omer, moving to me. Okay. Moving to me. Good English. Okay. So.
Perfect.
So my experience this week was, and I think you like it, I developed something with Nest.js, and the front end was Vite, Vite, no idea how I say it, with React, which is weird, but okay, because I like Vue.js or Vue if you know it. And the database is MongoDB. So I'm telling you the architecture that I dealt with this week, okay? MongoDB. And I also did all the authentication with Cognito, like AWS Cognito. So the whole application is Nest.js for backend. The database, again, was MongoDB. Front end was Vite with React, and authentication with Cognito. Why am I saying that? Because I was able to develop everything locally. So nothing in the cloud. So I got Docker Compose running local stack, which is running AWS locally with Cognito. And in that same Docker Compose file, I I got MongoDB. I'm also running MongoDB Express, which is the graphical user interface to see your MongoDB. You have other tools for that. You got Compass, you got many other things. And putting that aside, we also talked about it last week. I'm developing natively on my machine, Omer, like you like, with Nest.js and Vite, and they are running locally on my machine, not in containers, right? When I still haven't created the infrastructure in the cloud, I still haven't created the infrastructure in the cloud. So right now I'm only developing everything locally and testing everything locally, running everything locally. Once I start moving to the cloud, I'll write a Docker file, and then I'll do the trick that I told you.
I wonder if you'll try to deploy Compose onto ECS.
No. I wanted to do it like a long time ago, but then I realized and also I'm using MongoDB Atlas. So I won't need that, I think.
Right.
Yeah. So it was very fun, and I realized that Nest.js and Mongoose, if you know Mongoose.
Yeah.
Okay, so Mongoose, like the ORM, like for those who don't know, is the ORM for MongoDB.
I think it's in their docs, isn't it?
What?
Isn't it coming with Nest.js?
They talk about, so they got TypeORM and Mongoose, which is
I use TypeORM.
Yeah, so they are the ORM that you can talk with the database, which is very nice. I mean, the whole ecosystem that I just talked about, the whole info,
supports you through everything, security with Helmet, and
it was very, very, very nice. So I'm really enjoying the development process, especially because everything is on my machine, so everything is super fast. Okay, so this was my experience this week, and it's probably going to be for the next few weeks.
Amazing.
Yeah, that's it on my end. Anything else, Omer?
All right. No, that's it. I think we can wrap up.
It's going to be, I think, the longest episode ever.
Ooh,
okay, breaking record over
time.
Yalla, so
thank you.
See you next week. Yalla, bye.
See you. Bye-bye.